Hi, this is Mr. Nazarian. Today's learning objective is to simplify fractions by reducing them to lowest terms. So as you can see here, we've got two fractions. They're both the squares, they're the same size, but this one has been divided into 4 equal parts with 2 parts shaded. This one over here has been divided into 2 equal parts with 1 part shaded. But if I move this over here, you will notice that the shaded parts are exactly equal for both of them, which means that these fractions are equal. And another name, a way to say that fractions are equal, is to call them what? That's right, equivalent fractions. And we've worked quite a bit with equivalent fractions, where what that means is the value of the two fractions are the same, but the numerator and the denominator are different. So even though the shaded part here is the exact same, it's equal, right? One of them has been divided into 4 parts with 2 parts shaded, one has been divided into 2 parts with 1 part shaded, but they are equivalent, they're equal. So you would say that this is 2/4, right? Because there's 2 out of the 4 parts shaded, and this is 1/2 because 1 out of the 2 parts are shaded. So with equivalent fractions, what we have noticed is that what we've done up to this point is we usually have made the numerator larger and the denominator larger, and in order to do that, we have multiplied the numerator by a number and the denominator by the number. What we have learned as going through that process is whatever we multiply on the bottom, we have to multiply that same number on the top. Whatever we multiply by on the top, we have to do the same on the bottom. However, when we're reducing fractions, it means that the number on the numerator is going to get smaller. We're reducing it. The number on the bottom, the denominator, is going to get smaller. We're reducing it. So we're not going to be multiplying, because when you multiply, things get larger. When we're going to do the inverse operation of multiplication. What is the inverse operation of multiplication called? That's right. It's called division. So we're going to divide the top and the bottom by the same number to get an equivalent fraction. So 2 divided by what equals 1? That's right, 2. So again, we have to do the same on the top and the bottom. So if we divide by 2 on the top, we divide by 2 on the bottom, and that checks out because 4 divided by 2 equals 2. So we've already proven that 2/4 is equal to 1/2, and that is a way of also showing it. That's what we're doing mathematically. Again, the reason for that is because if we divide by the same by the top and the bottom, that means we're dividing by this one by 2/2. Well, 2/2 is equal to 1. If we divide by 1, we're going to get the same value. All right, so let's look at this next one here. So if we have 3/9 and we wanted to reduce that to lowest terms, we want to find an equivalent fraction where the numbers on the top and bottom are both smaller, but we have an equal value to 3/9. We're going to need to find, so here's one difference though also of when we've been finding equivalent fractions and multiplying by the top and the bottom by the same number, is because there is an infinite amount of numbers that you could multiply by, right? I could multiply, if I wanted to find an equivalent fraction for 3/9 where those numbers are going to be larger, I could multiply by 2 or 3 or 10 or 18 or 5,376. It doesn't matter. I can multiply a number by any number I want. But to reduce fractions, we're going to divide the top and bottom by the same number, but the amount of numbers that you can use are limited to only factors of both the top and bottom number. So I have to find find what is 3 and 9, what are they both divisible by? In other words, what number goes into 3 and also goes into 9? So for example, that last one, I was able to divide by 2 on the bottom and 2 on the top, because 2 goes into 2, it also goes into 4. I cannot divide by 2 here because 2 doesn't go into 3. 2 doesn't go into 9. I can't divide by 2 on the top and bottom. So I have to divide by a number that will go into 3 and 9. So what number goes into 3 and 9? What is the common factor of 3 and 9? That's right, 3. 3, if I'm counting by 3s, the first multiple of 3 is 3, right? So 3 goes into 3, and it also goes into 9. If I'm counting by 3s, I would land on 9 also by the third multiple, right? So again, the reason for this, we're dividing by 3/3, means we're dividing by 1. We're going to end up with an equivalent fraction. So 3 divided by 3 equals what? 1, good. And 9 divided by 3 equals what? 3. Good. All right, so 1/3, I've found equivalent fraction. I've reduced these numbers, so I have a little bit easier number to work with here. So 1/3 is equal to 3/9, and I know that that's the lowest terms because there's no number that goes into 1 and 3 besides 1. And we're never gonna do that. We're never gonna say, well, 1 can go into 3 and 9, so I'm gonna divide by 1. Because if we did, we'd just end up with 3/9, and then we'd do it again and again and again, and we'd all be very tired and very old and very bored, and we'd have the same exact fraction. So we're only looking for numbers that go into the numerator and denominator that are not 1. Don't use 1. All right, so 1/3, we're done. That's lowest terms. This next one, I'm gonna do it a certain way to kind of show off a point here. So if I look at 8/32, right, 8 over 32, and I want to find a factor of 8 and 32 that they have in common here, one thing that you might notice is that 8 and 32 are both even numbers, and we know that all even numbers are divisible by what? What number goes into all even numbers? 2. So I know that I could divide the top and bottom by 2. That would work. 2 goes into 8 and it goes into 32, right? So if I do that, 8 divided by 2 equals 4, and 32 divided by 2 equals what? 16. Okay. So now 4/16 is equivalent to 8/32. I have reduced it. However, I'm going to remember, if the object is to reduce them to lowest terms, then when I look at these, I want to look at this again just to make sure and say, well, okay, I've reduced it and I have 4/16. Can I reduce it more? In other words, is there a number that goes into 4 and also goes into 16? Now, you might be thinking to yourself, well, 4 and 16 are both even numbers. I could divide by 2 again, and you would be right. You could do that. However, let's do a little shortcut here. Is there a different number that goes into 4 and 16 that I can divide by instead of 2? 4. Okay, 4 goes into 4. 4 also goes into 16. So I'm going to divide the top and the bottom by 4. 4 divided by 4 equals 1. And 16 divided by 4 equals 4. So now I have 1/4. Okay, I know I'm done. The reason for that one thing is I could say, is there a number that goes into 1 and 4 besides 1? Nope, there's not. Anytime that the numerator is 1, I know that I'm done. That's the lowest terms I can possibly get, because the only number that can go into 1 is 1. And I'm not going to divide the top and bottom by 1, because I just end up with 1/4 again. So there you go. All right, last one I want you to solve yourself. So go ahead and reduce 12/18 to lowest terms. All right, good job. All right, so this is what we're going to do. We're looking for a number that goes into 12 and 18. Now what I'm going to do, what I like to do is I like to look at the numerator. And first I'm going to try with that. Is 12 go into 18? No, it doesn't. So I know I can't reduce by 12. So I'm going to think of other factors for 12. Well, I know that 6 goes into 12. Okay, maybe that'll work. Does 6 go into 18? Yes, it does. So I'm going to divide the top and the bottom by 6. That is going to give me 12 divided by 6 equals 2, and 18 divided by 6 equals what? 3. So now I've got 2/3. I'm going to ask myself, can I reduce this more? Is there a number that goes into 2 and 3? Can I divide by 2 or 3 by the same number? Nope. The only 2 is a prime number, right? So, and actually 3 is also. So the only number that can go into 2 is 2 and 1. I can't divide 3 by 2. So that's not going to work. So that means that is reduced to lowest terms. And that's it. So that's all we got today. We're going to work more on this tomorrow. And let me know how you're feeling at the end of this question. All right. See you tomorrow.